Hello everyone. Today we are going to discuss one problem on the concept of Euler's method to solve first order ordinary differential equation. Okay. In previous video we have discussed it and now we are going to discuss one problem. Okay. So what's the problem here? The problem is using Euler's method, find an approximate value of y corresponding to x is equal to 1 given that dy by dx is equal to x plus y and y is equal to 1 at x is equal to 0. Okay. So what we are given here, that is dy by dx is equal to x plus y, and we know in Euler's method dy by dx is as same as equal to function of x and y. Okay, so that means here function of x and y is equal to x plus y. Okay, and what's the initial values are? Initial values of x and y are x is equal to 0 and y is equal to 1. Okay, and so we denote it by x naught is equal to 0 and y naught is equal to 1. Then we have to find y1 in this question. Okay, that means the value of y when x is equal to 1. Okay, so what we have to do first of all, we have to divide the interval from 0 to 1 in 10 small intervals, okay, of width 0.1. In this question particularly, we are going to take just h is equal to just 0.1. You may take it 0.2 here also. Then there will be 5 intervals, and if you take the h, the value of h is 0.1, then it will be 10 intervals there. So for accuracy, for better accuracy, how many intervals you take, as you many intervals you take, then you get the better accuracy. And if you take the little intervals, that means the few intervals, then you will get some little accuracy there. Okay, so we started from taking h is equal to 0.1 with initial value of x naught is 0. Okay, so what we represent here, y when x is equal to 0.1 is this, and it is y1 we take. Okay, so similarly y when x is equal to 0.2, that is this, and that is represented by y2 here. Okay, so if we increase this screen, okay, and now y2 is equal to y of y when x is equal to 0.2, y3 similarly y3 is equal to y when x is equal to 0.3, and so on, y4 for y 0.4, y5 for y when x is equal to 0.5, similarly y6, y7, y8, y9 and y10. Finally, when x is equal to 1, then y1 is represented by y10. Okay, so what we know by the derivation of Euler's method to solve first order ordinary differential equation is, we know here, so y1 is equal to y naught plus h fx naught y naught is equal to what we take here. So y naught we know, that is given, and that is here 1, and h is equal to 0.1. Function, what is given? Function of x naught y naught. So we are given already functions value. Function is this here. So f of x y is equal to x plus y. So in place of x we write here x naught, and in place of y here we write y naught. Okay. So that's value is x naught plus y naught. Okay. So y we put here. Okay. And then we finally conclude that the y1's value is 1.1 is here. Similarly we find y2. What's the y2? Y2 is here y1 plus h into f of x1 y1, and similarly we substitute the values of f of x1 y1, that is x1 plus y1 for this question. And for other questions you may take here the values of function of two variables x and y, what is given here. Okay, that is derivatives value is known as the functions of two variables x and y, that is okay. And similarly we can find y of 0.3, that means y3, by substituting x2 y2 in this function. And similarly y4 y5 y6 y7 y8, and the final one will y10, that means the value of y when x is equal to 1, and that will be y9 plus h into f of x9 y9, and that will be find by here. Okay, so that's will the final value of y10, that means the value of y when x is equal to 1, that will be the final value, that will be 3.18. That means the value of y when x is equal to 1 is 3.18 by Euler's method to particularly this question. Okay, so finally I repeat this thing, you may take it h is equal to 0.2 also. It is not, if it is not given in this question. Okay, sometimes it is given in this question, in that type of question, that you have to take the you have to take the differences here. H is equal to something is instructed in the question, then you have to take it as according to your question, and if it is not, then you may take any value of h. Generally we divide in 10 intervals, sometimes we may divide it in 5 intervals also, and similarly we can do. Okay, in next video we will do some more concepts. Okay.